video for you, buddy. Wes, I'm starting all over again here. I'm going to make this video for you to show you a little bit about how I test the cells. And I mark them, and then you run it through Repacker, okay? Now, I got a couple different charger, and this right here will test your cells, okay? This one is an Opus BT 3100. This one is nice. I like it. It's the first one I got, but I like these better. Okay, these right here don't have a fan in them. This one does, but these right here will charge a cell even if it's almost dead. And I've had some that come out of some of the laptop batteries that I've salvaged, and these would recognize it, and these would just start at a low voltage and then charge it up so far, and then it would start over, and then it would continue charging and finish it up. So anyways, I got some cells down here in a bucket. I'm going to show you what I usually do. Now this one right here, as you can see, already has the capacity put on it. Okay, 1986. Okay, 1986. So it's right at 2,000 milliamp hours. Okay, so this is probably 1,800 milliamp battery. If it's, I think it's fairly new. It came out of something I salvaged. It's a LG DA. DAS 318650. Okay, so these, I get all kinds of different colors when you're salvaging, but a lot of times these are just like brand new. I mean, they, once you get them out and you clean them up. So what I do is put them in here, and I'm gonna hit to set the phone down. I don't know if I can do this one-handed, but okay. So, and this is a Zan flare. Okay, and I don't know if you can see it or not. There you go, Zan flare model C4. Okay, and I can send you a link to that where I got it on Amazon. I actually got two of them at one time because they had a sale. So anyways, once you get the battery placed in there properly, and for some reason here I am not getting, oh, it's not touching the cell. It's got a piece of black paper on it. Some of these have like a whole piece of paper. I don't know if you can see it or not. There it is. And it's kind of like a little insulator. And sometimes you got to play with them a little bit to get them. Either that or take that insulator off. So for the video, I'm just going to get another one here and see if I can get one to get contact. There we go. Anyways. Then automatically start sensing the battery. And this thing will work with several different sizes. You know, it's not just 18650s, but these right here chargers will work with just about all the different chemistries. They'll work with lithium iron. There's several, but the main thing we're dealing with is lithium ion. So this will start out charging automatically, okay? And then, of course, there's two buttons on the front of it. And this right here is for different charge settings. And you can actually increase this to 500 milliamps to 1,000. Okay, it'll go 5, 7, I think 1,000. So if I push and hold this button, that puts it in the settings mode. Okay, see how it's flashing? Then you go here, 700, 1,000. So you can actually charge it at 1 amp. Okay, this is your milliamp, 1,000 milliamp, which is 1 amp. Okay, or you can do it at just 500. And of course, it quit blinking, so right now I'd have to push this, get it to flashing, and we can go back to 300 if you want. It defaults to 500. So you can slow charge at 300. I mean, it don't hurt them at 500, and I've seen a lot where it says don't charge them too fast, you know, individually at say 1,000. But you know, if it's a fairly new battery, it probably won't hurt it. But just, you know, that's just kind of some recommendations, and most of these chargers just charge a certain rate. Now, if you just push this button, it's going to give you your voltage. So right now, I got 4.6 volts in it. And this is the milliamp hours, which what it is, just gives a recording of how long it takes to charge. And this is the resistance, 422. Now, a lot of them say the resistance is fairly important, but I've seen some batteries that showed 200, 300, and like this one here is 400. The newer batteries, when I bought brand new, I noticed they was like anywhere from under 100, that'd be 70, 80, all the way up to over 100, some of them over 200. Okay, so if you can stay below 200, great. but there may be some of them resistance wise, and what it is, it's just measuring the internal resistance of the cell. So how much resistance it has in that cell. And basically, they say the higher the resistance means the cell is just getting toward the end of its life. So you can take that for what it's worth, and there's a lot of research out there. It goes both directions, and just kind of have to, if you want to do further research on that. So if you want to hold this right here till it flashes, then you can put this into testing mode. Okay, see, this right here is a fast test, normal test. The normal test will actually charge this up fully, and then what it'll do, it'll discharge it all the way down to the lower limit, which is around, I think, 2.7 or 8 volts. Okay, these cells can go down quite a ways without hurting them. So the lower limit's around 2.7, 2.8. I like to try to set mine up the way I got them set up to stop at around 3. That way you're not going too low and you're not going too high. Charge them up to 4 volts, not 4.1 or 4.2, but 4 volts even. And that gives you a good range of capacity to use, and it's going to make them last longer. You'll get thousands of cycles instead of hundreds. These right here last a long time, and you can do a lot of cycles. And that's what's kind of the bad thing about the lead acid. They don't have a very long cycle life, and they sulfate, and you got all these other issues. You got to add water, fumes, so on and so forth. So anyways, once that gets done, it will display a capacity, okay? And then what I do is write on here what the capacity is that this came up with. Then I'll put a slash mark, and then over here a little farther, I'll put the resistance. So I'll just push the button here and get it to the resistance where it shows the resistance, okay? So, yeah, MR, that's your resistance right there. So that's not the voltage, that's resistance. So anyways, then I'll put the resistance on the battery, the capacity that I come up with. Then you go through all your cells and you run them through one of these, or get you 2 of them or 3 of them or whatever. I mean, the more, the quicker you can run them through. Write that on there. Then you go to Repacker, like I said, and I'll send you a spreadsheet on how I do it. See, these are all got the capacities on them. And this is one I'm working on now. It's a double-sided. You actually can add cells on both sides. Most of them I've worked on so far and built. And then see, this is your ribbon connection. That's a ribbon for the balancing. And so this one right here, actually, I'll be able to put 14 cells per board. The ones I got right now only have 7 cells, just got that top row. But I found these right here at a pretty reasonable price. And you get 2 and then 1. So you get singles. So you could actually buy singles, but these are more expensive than these. So what I do, and what you do is, I found these are a little cheaper than these. So instead of putting all singles, but 2, 4, 6, 7. So, and you can do it however you want. You can put 2 and then a single. But these right here fit perfectly on the soldering contacts that's on these boards. And the guy that designed these actually designed them to be used, both sides if you want. Okay. Now he even showed some in his video. That's Jehu. I think I sent you a link to his channel. But see, these right here got little pins, and they go through the holes that are in these boards. And there's a free Gerber file that we can send to jlcpcb.com. It's a site. What they do, they build PCB boards, and that's what this is. And he designed these, and it's been handy, and it makes it modular. You can you stack these things up. You use these little standoff pins, and of course now I'm gonna have to double the size of my pins, but I don't have to buy as many boards. So the boards average around $2-3 a piece, plus all the hardware you have to add to it, plus all the cells. So you can run into a little bit of money, but if one of these cells go bad, die, I just pop it out and pop in another one. Find one that's got a really close capacity, and of course, once you start noticing, imbalance, because what happens is, if one of these cells, say, goes bad, what it'll do, it'll start draining the cell below it, and the cell below it, and the cell below it, so they'll get way out of balance, and they'll stay out of balance. And this right here, ribbon connects each board to the next, okay? So then you got a whole stack. And then so the BMS I'm using right now, you can actually program it to balance all the time. So what happens is, like I was saying earlier, instead of the BMS only balancing these cells to 4.2, which a lot of balancers are set up that way, whether it be a 7S balancer or a 14S, which that's what I've done. I took a 14S and I figured out how to make it work with two 7S's. And I'll show you how I done that. It's pretty neat setup. And it's Bluetooth connectable. So basically, you just got to get within range, and then there's a program. You access that program, and I can turn off these cells. That BMS will actually shut that whole battery off. You don't even have to have a switch. And then you can go in and you can program your high, how high you want them to charge. You can program how low you want them to discharge. It keeps track. It's basically was designed for this BMS was designed for e-bikes. And so I guess there's a lot of that going on over in China in that area. So this program is kind of made for that, but it works great for this right here. And of course you can control it, and it has right on the on the program, you can actually, when you access it, it has a big lock symbol, and you click on the lock symbol, it shuts the battery off. I mean, how cool is that? You know, you can shut that bank off, and if you got all your banks, you know, like you got several, like you see now in my picture, you can shut whichever ones you want off and turn whatever ones you want on. And they're not that much more expensive than the ones that I've been using for these. Because I started out using 7S balancers and basically putting one on here and one on the other one and connecting them together. And it just wasn't working very well. So I found this one that's a 14S. And then I was able to split the 14 up into two. So seven of the connections goes to this board, 7 connections goes to the next board, and basically it sees it as one big 14S battery. Okay, and all you're doing is paralleling or seriesing this pack with another pack. You know, so you're taking a 48 volt system or 24 volt system and making a 48 volt. But like I said earlier, you make sure your charge controller and make sure your inverter will handle these voltages as high as these got to go, because a lot of them are set up for lead acid. And the one I'm using right now is I think it's a 60 amp charge controller, and it's programmable for lithium. And you can actually set it at whatever voltage you want, really. You know, I mean, I got set right now for 57 volts. So what it'll do, it'll charge these up to 57 volts, and it'll stop. It'll just stop charging. But then you also have the BMS protecting your boards. And these right here also have fuses. Let's see if I can get in here close enough you can see it. That's the top side. Okay, this is the bottom side. So these are all fused. And if you see right there, that's a fuse for the whole board. So if anything in here shorts, it causes 5 or 6 amps of draw, it'll burn that in two. This board is out of the pack. The rest of them will continue to work, but it takes this out of the equation. Okay, same way here. If these fuses, any of those burn because of one of these went bad, what it'll do, it'll blow that fuse, and then that takes this whole board out of the equation, just like that. So it could go either way. It's like a double protection. But I've played with these for quite a while, and these have to connect because it's series. See, you're positive, negative, positive, negative, positive, negative, all the way across until it gets down here, and then it makes the full connection. So you can actually put 3 or 4 batteries in this. There's no power up here, okay? And these right here, lugs right here is where your power comes out. See, positive, see the positive there? And this is got contacts on both sides. See? So when you put your standoffs, they're brass, and they make the connection from board to board. Now you can use these right here, and he added this, and you can use what's called XT60s. And these right here are made for XT60 connector that they use in hobby, which will go up to 60 amps. But I just use these connections, and then use these for the ribbon. And then there's a 16 port ribbon that goes in this. And at first he had that to where it was just using 8. But basically it's using 16, but these 2 is for that one battery. These 2 is for that one battery. So it's kind of a double redundancy. And the ribbon you plug into this, you're setting up the same way. You're only using 8 So you're doubling everything. So it's a 16 ribbon, but you're actually cutting it and making the connection. And I'll show you. Here's a ribbon I've created. Okay, I'm trying to make this video too long. So this is the ribbon I created. This plugs right into that. Yep, find my thing here. This fits perfectly into this. Okay. So when that plugs in, and I went down here and I took these and I stripped them. And then so this is the ground side. I always use the brown in that first red. That's the ground side. So I put those two together for the first one, and then the next one, and the next one, all the way across. Okay, so you got a ground, and then you got 7 connections for each cell. Okay, and then this goes out to a balancer. And I bought these leads. These leads are cheap. And these right here will go into a, what I got is a Sky, what is it? Yeah, it's Sky RC. And it's a multi-function balance charger. So while I'm doing a lot of playing around with just single boards, this thing is very handy. It's a dual charger. It's a hobby charger. And it's got all these different connections. And you can run all the way up to 7S. Okay, this right here is hard to find. You can't hardly find very many 7S chargers. But I wanted to have something like this. That way I could do testing, you know, charge, discharge, balance the stack. Because you can do these individually if you want. And let's say you get one that's kind of out of balance. I can bring it in here and put it on that charger and it will balance them. And you can do individuals, or I can do a whole stack. Okay, so that's the nice thing about it, because this is a 7, and even if it's 2P, 3P, all the way up to 10P, I can put it on there. It takes a while, but it'll balance them. Okay, so but since I found this new balancer, it works really, really well. So that thing doesn't get used as much as it used to. But this right here kind of give you a little bit more of an understanding of why we do this. Okay, and I'll send you that sheet. And that way, you know, this capacity of this cell and the capacity of the cell on the bottom of it, and so on, you know, in that stack of 10 or 20 or how many you want to make. I would only go like 10. But, you know, you can go as many as you want. But Repacker will tell you, okay, put this capacity cell with this specific cell down here. And that way each group is the same, okay? Because if this group capacity-wise is bigger than, say, this group, and you know, all 10 of them this is smaller, guess what? This is going to get out of balance because all these are going to go down discharge-wise differently. Okay, now the nice thing about having this new balancer I got, that may not matter, and that's something I got to test. Because if it works as well as I think it does, you can basically not have this perfect and they will discharge and still balance. But the problem is, if they ain't balanced across the board, that charger or that BMS, when it sees this cell get low, let's say 3.0, these all may be at 3.5 or 6 or 7. See, so that's another reason for having your capacities matched, because that way you get the full use of all the cells. Otherwise, if this is mismatched throughout, say, the 10P, then these right here will still have a lot of energy left in them, but it's going to shut the whole, you know, this whole pack down to save these cells. So if we spend the time to get the capacities, run them through Repacker, and then put them in line, and you'll see when I send you that sheet how close you can get them. I mean, it will get them really, really close. And that way they look almost equal from cell to cell to cell to cell. So that's 10 cells, 10 cells, 10 cells. But, you know, it'll see it as basically one cell, 7S. Okay? So I'll send this out to you, and I'll get that sheet to you. All right? We'll talk to you later, Wes.